Hello, and welcome back to Learning with Lee. In today's episode, we are going to take a look at manipulators and how they can be used to modify the state and formatting of streams in C++. And manipulators take one of two forms. The first form is similar to this no skip whitespace and this skip whitespace. And what these are is they are just functions, and you can see them in here. They're very short, easy, efficient functions. Because what their major goal is that they are going to be setting or unsetting certain flags within our cin or cout or within any other stream that we end up using. So it ends up changing flags or changing state within those objects. So as that those flags and those state then end up modifying how those streams end up reading in and writing out data. So in this case here, saying that we want it to not skip over whitespace, once that flag gets unset, because by default there's a flag that's on called skip whitespace, and you can see that in here, and all of these flags exist within iOS base for their namespace. And what they happen to be is it tells it whenever we hit whitespace, such as this little space in here, treat that as a delimiting character and split off the input or split off the output. So in this case here it would be like, okay, we have our input here, then we have this one, and then we have this one. However, with this flag unset, we would just read until either we hit the end of our stream, or we would end up having to set something else, such as down here with SetW or setWidth, in order to specify the number of characters we want to read in. And that happens to be a fairly elegant way for dealing with things such as in case I want to read in an entire string without caring where its whitespace is, such as in case I'm dealing with like a text document in Word. The fact of the matter is that I'm not necessarily going to want to just tokenize that when I read it in from a file and split it up by every single word that happens to be within that document. Because that would be horribly inefficient, and I'd have to do a whole bunch of additional logic to reconstruct the sentences and the formatting that the user had there. It makes much more sense in order to have that done as though the whitespace is important to that context. So there's a very good reason why you would want to unset this flag, but for many other different files, you do want the flag to be set so as that in case you're dealing with integers and you just are using a space between them, you can easily get each one of those integer values out of that file and into that file without having to worry about two of them being side by side or having to do any additional parsing on your end. What this ends up doing is, because of the fact that it is a function, it means that the object that cin and cout happen to be based upon for O streams and I streams has particular overloads of the operator for either double greater than or double less than that ends up taking in a function pointer for one of those variants. Because they already have overloads for things such as doubles and character pointers that handle those independently. However, for this one here, what you're looking at is it needs to take in this particular definition of a function. And the major things are that it needs to return a reference to an iOS base, it needs to take in an iOS base reference, and the name doesn't really matter, it's whatever you want it to be, but that's really the major thing. Because what then does is, as this argument here, cin or cout will end up passing in itself, or use the this keyword to pass in a pointer to itself, or it'll do the this followed by a dereference, so as you end up getting a reference to itself. One of the important things that I don't remember if I've gone over or not is that you're not allowed to actually copy these streams. And it makes a fair amount of sense because, in case you remember our discussion on file pointers, where we end up dealing with the fact that there happen to be these buffers and they happen to be well-defined buffers by your operating system, you can't create a copy of that buffer. That buffer happens to be a system resource that is not clonable. So that's the reason why you'll find that basically all of these end up dealing with streams by reference. It's why, in case you remember earlier on, when we initially introduced this operator during our linked list section, why these always end up being passed in by reference and not by copy. So what it does is it passes itself in by reference. This typically is then going to end up calling either setF or unsetF, which ends up meaning that it sets or unsets a flag within that class that modifies the behavior of that stream in some way, shape, or form. In this case here, by removing the flag to skip whitespace, it will no longer tokenize input as it normally would into, say in this case here, 3 different tokens, followed by this little quotation mark would be technically another token. that happens to be what no skip whitespace has done, and that's also how basically every single one of these manipulators is written, with the exception of one type of manipulator. And that's that these type of manipulators, due to the strict way in which function pointers need to be defined, due to the fact that it must have this specific return, this specific argument, it means that you don't get any other arguments. So something such as down here, SetW or setWidth, ends up being a bit more complicated than just having it be a function pointer, because of the fact that it needs to take in an integer value to tell you how many characters you either want to read in or write out. And SetW is very useful for formatting tables, for creating stuff so as that you end up having consistent widths in each of your columns, and being able to do stuff that ends up either being left aligned, right aligned, center aligned, and having it make sense in that manner. But there is a few limitations of it. The first thing is that for SetW, it only impacts the next thing you read in or write out. So down here, you'll see that I have these 3 SetWs, and that's because I wanted to write out 10 characters for each one of these, but I couldn't just set SetW and then leave it throughout there. And one of the important things you'll know with something like no skip whitespace is that I need to then do something like skip whitespace, or either set flag or unset flag, in order to toggle that state into the other state, because it stays that way for multiple inputs and outputs. And you can see down here, in case I scroll down slightly, is that we take a look at our inputs down here, where I ended up taking in just the word test. As you can see right there, output it. And one of the major reasons why you use SetW is that if you're reading into a character pointer, you actually don't have a limit in terms of if there's 50 characters here, I could give it 100 characters, and CN is not going to complain about the fact that there are more characters being read in than there is space in your array. It's just going to crash your program. So making certain that you set W to make certain that you get safe amounts in. And you can see here how we have this really long string here, and it ends up getting split at 20 characters, or more accurately, 19 characters, because the important thing about SetW is that the last character that you would be getting, that 20th character, is going to be your null terminating character. So as to make certain that you don't end up then reading beyond the end of that string, beyond the end of that 20 characters. And then this one here, as you can see for the third output, SetW does not apply for that one, even though I never did anything to unset that flag. It only applied for the second one. But now as for how SetW actually works under the hood. And that's that SetW is a class. It's an object. It happens to be something that you initialize in its constructor with a decimal, with an integer. And the reason for that is that you need to specify its width, but you can't do it in this way up here because of the fact that it has this particular definition for these here. And there could be many different ones that you want to do your own custom manipulators. So what you have to do is you have to create your own class that overrides this particular operator, or potentially also this particular operator, depending on whether you want to input or output. And what it then does within there is it then needs to modify that stream that it gets passed in, because it's going to, similar to how we have over here, we take in a stream, and then we take in this case here, a polyhedron reference or polyhedron pointer, because of the fact that these are friends and they aren't associated with any particular instance of this class. But you would do a similar thing for, in case we hop back over here, SetW. And what it then would do is it would go, okay, I'm going to then modify CIN so as that it only takes in a certain number of characters for its next input. So those are the two major types of manipulators where it is either a function or a class. So let's go through the major manipulators in C++ right now. I've already gone over things such as no skip whitespace, and what their value is. You can see what setW does down here. So then the next thing is that you can combine things such as setW, left, right, internal, as well as setFill in order to do things such as, you can see down here how we have these left aligns and right aligns. As you can see, setFill, I got set on this particular one here. And once again, this one here, similar to setW, is going to be a particular class. And you can see in here how it has this template class InLine, does that. And what ends up happening with it is that it ends up setting a flag, but that flag lasts for multiple inputs or multiple outputs. Beyond here, and those are really just ones that are common for, in particular, number input and output as well as character input and output. There are also some for Booleans. And those ones are things such as bool alpha and no bool alpha. If we scroll on down here, you can see how it goes from 1, 0 to then true and false. So you can see up here how we have this bool alpha, and then it does these as true and false himself, and then it does that. We can use it for input. So you can see down here I input 1, gives that correctly, did false, gives us now 0. And now there happens to be a very important thing worth noting in here. And that is that we are going to enter into what is known as a fail state for our stream. And that means that it failed to store whatever value we put in this case here, t, into what we ended up dealing with. So in case you give an incorrect one, you're going to either wind up in a bad state, which you can check via this bad function or method, as well as then a fail state. And the thing is, if it's in a bad state, it's also going to be in a fail state. But being in a fail state does not mean that it's in a bad state. A fail state just means that if whatever input it had was valid and the stream is still good and still useful, but it wasn't able to store it in whatever you tried to just store it in. And it can lead to some problems down the road, but a bad state means that the stream basically, you don't know what's going to happen because there is something wrong with the stream presently. It has some more negative connotations with it than just a fail state. And there is also a couple of other things that you can do, and those are things such as I could do cin dot, and there's good, if I do a quick little, whoops. And you can see down here how there's a good bit, and good just basically checks whether or not that good bit is true or false. And these are all internal flags within these objects. And then, as I had mentioned, there's setF and unsetF, and this is the direct way of setting and unsetting flags. So is it normally you end up wanting to use these manipulators, but if you want to create a custom one, you'd have to end up using setF and unsetF. And there's a few different situations where you can use a manipulator to set something, but to unset it to the default value, you have to use unsetF. And we'll get into those in a second when we get down to some of the stuff involving doubles and integers. So in this case here, you end up passing in one of these, and you'll note that it just happens to be a little enumeration or type name within here for it. And what it'll end up doing is that it happens to, and all of these for the most part are within iOS base. So there's a whole bunch of these. So if I just hit here and do this, you can see all of these different enums that exist within iOS base, and pretty much every single one of these happens to be used for something you can either set or unset. cin.clear just was to basically reset the state of the stream from where it is, but clear can also end up throwing exceptions. And the vast majority of these don't throw exceptions, but clear can. So that happens to be one of the distinct aspects of clear. Then we can scroll on down to here, where we end up dealing with doubles, and also, to a certain extent, integers. So the first thing that you're going to note is that we can do things such as similar to before, where we output things either in decimal, we can output things in hex, we can output things in octal. We can use showbase in order to get this 0x or this 0 to specify either whether we're in hexadecimal for 0x or 0 for octal. We have no showbase in order to basically undo that, in which it does the unset f, and within showbase it does set f. And one of the important things is that for decimal, hex, and octal, you have to then use unset f to undo that particular case. So in that case there, you have to then undo it using this iOS base field. And there's really a few different ones of these, and you'll see another one of them down here with float field, that happen to have these multiple different manipulators that can assign a particular flag to it. And you see within here how it has this set f, and it calls then iOS base hex, and then also the second enumeration in order to specify which flag it is that's getting set to this value. So that ends up being a bit more complicated of a version of a manipulator, but at the same time it follows the same general paradigm and design patterns as before, so it's not that much more complicated. Then down here, a few important things to note. You cannot output in either octal or in hexadecimal something that is a double. You can only output integers. So you'll note here this 123.456 still comes out down here as 123.456, even though I've explicitly included this oct right here. I didn't need to because of the fact that I already had it up here, but I wanted to make certain that you could see that I was trying to output it in octal, and it's still output it in decimal. And you can see down here, for after I've unset it, we output 55 here while it's in octal. Still, even though I don't have octal on this line, in outputs it is 67 because that happens to be the octal version of 55. But down here, after unsetting the flag, we get 55 out. Then also down below there, we're going to output a double. And once again, as we did in fprintf or the like, we could use %e in order to get in scientific notation. In this, you just use scientific to get into scientific notation. And you see that right down in here. One of the other things you can do is you can specify whether you want your e's to be uppercase or lowercase. So if you use uppercase, it ends up generating this, where it has the uppercase E. However, you might think, okay, well, that's going to convert all of my text to uppercase. However, as you can see on this line down here, as well as right here, it does not convert this to uppercase, even though I've expressly told it to. Then also use no uppercase to undo that. Technically, this uppercase here is extraneous. It's not necessary, but it's just there to make it clearer as to what I'm trying to do and what I'm trying to show. Then there happens to be precision. And precision is basically what we ended up doing with the number after the decimal point in C. So for this, you can see how in here we end up having our precision of 15, and now we actually have our correct number of values coming out down here, though we still happen to be for now in scientific notation. So I would have to undo that in order to have it still in the correct type of notation. There's 3 different types of notation for this. There's scientific, there's fixed, and then there's general. And the way in which you get general is the default one, as well as you can undo it by using this float field flag in case it happens to have already been set by either fixed or scientific. So that happens to be a bit of the work you can do in there in order to get different varieties of output for doubles. But as you can see in here, we end up getting out the 15 values in here for our precision, and it adds on these zeros at the end in case we don't have enough information there. And you can see for like this one here, how it ends up dealing with this. And one of the important things about doubles is that it does end up rounding them for scientific notation and for any normal use of doubles, similar to what we did with C and how I pointed out the fact that it ended up rounding it when it by default cut to off its 6 after the decimal point. And for fixed, it ends up being similar to %f in C in that it does this 6 after the decimal point. It isn't quite as flexible to a certain extent, but at the same time, it works very similar to that. This general happens to be similar to %g in C. And basically when you are doing that, it goes, okay, well, my precision is the total number of characters I want. So it would be 6 by default, whereas with fixed, it's 6 after the decimal point. And for scientific, it would be 6 after the decimal point, but then it's also in scientific notation, so it's over here. So show pause, that's saying show the positive sign in case we end up having it be positive, because in case it's negative, it will always show you that negative sign. But once again, we went over the flag in C in order to do that same thing with fprintf and the like. So that happens to be the majority of the different manipulators that exist in C++. They're all fairly similar to what existed in C beforehand. There's a few others that I haven't covered, but I'm going to leave that up to you in order to research them, find them out for yourself. I recommend spending some time trying to create some tables. Try out putting something like baseball or football stats in C and C++, just so as that you can end up getting a hang of how you actually read in and write out these different tables. In the next episode, we are going to take a look at both file I/O and a more complicated real-world example of how we would actually write something in order to read in and write out an object that is a bit more complicated than anything we've looked at thus far, but is a more realistic example than just these test strings and examples within here. Thank you very much for watching. Have a wonderful day.